And can I start? No? Okay, thank you. So I'm going to start my presentation, monitoring in 17. And my name is Takehiro Sugita. And so let's start presentation. And my name is Takehiro Sugita, and I'm the information system guy in this preferred networks. And I work formerly as the SRE, or a security engineer, and or a security officer in the formerly job. And before that, I worked as a cloud service developer. And even before, as a network engineer or a part-time job as information systems. And I'm a fan of Prometheus. This is a quite modern type of monitoring system. And this is the Prometheus pose. I really love it. And so, in my career, there was always the monitoring right on my side. So I started as network monitoring, and then the server monitoring, and application database, and looking at the service in black box way, and then security monitoring. So there are many kinds of monitoring, and I've tried many types of monitoring. So what is a monitoring? So we all know that we need monitoring, but not all of us are pretty sure that why or what for do we do the monitoring. So let's look at the book. This is the 2012 Monitoring and Alerting. This in O'Reilly, and this says that monitoring is made up of 3 parts: data collection, data aggregation and storage, and presentation. So I guess most of you agree that basically a monitoring system is like this. We collect data from switches, servers, and firewalls and routers and everything, every devices, and then store the data in the monitoring server or the database. And then do the presentation, which means alerting to human beings or let us see by visualizing them. Basically, like this. And in the other hand, another book called Practical Monitoring. This book is released on this year around summer, I guess. And they say that there are 5 components. Collecting, storage is the same. And they say that presentation is in 3 ways: visualization, analytics and reporting, and alerting. And this is quite general and concrete enough to be picked up as an important element of monitoring, I guess. So in 2012 and 2017, things have changed. And in the monitoring system, everything is changing so rapidly these days. So 10 years ago, things are even more different. Like hardware specs and architectures have changed since then. And in 10 years ago, we couldn't say that we had cloud computing. And there were many great tools since then. So let's look down at each component's things. So hardware specs have really changed. We all know that we don't use any more IDE hard disks, and we can buy NVMe hard disks, SSDs. It's so cheap, and CPU can be used. And if you see CPU usage 100%, that doesn't always mean that your program is really running. It may be time for the data fetching from the main memory these days. So metrics will change over time. And monitoring, but the monitoring template doesn't change that much. So that's a big problem. And cloud computing is has emerged on this 10 years. And we all know, no, sorry. Maybe it's a very famous thing, the word cattle, not pets, in monitoring. But this is not what I'm going to talk about today. The real point is that traditional monitoring tools cannot go good with the cloud computing because they don't cope with host downs or use of IP address again and again with different instances. And about the tools, in the old days there are many problems. I'd like to choose one, this one, the one in the middle. There was if you do too much monitoring, then the network hardware goes down. So you can't pull into them like each 1 minute. So we were said that we have to pull it each 5 minutes. And that made monitoring rough and tough. So tools restrict our way of thinking. And in these days, monitoring tools are getting more and more modularized. And you can use it any way you want it. And you can just choose Kibana and Elasticsearch, or maybe Grafana and Prometheus, and then you can do the log file monitoring by using Fluentd or MTail, collecting general data using StatsD. You can use it any way you want it. So everything has changed so much, and is monitoring changed so much? Let's look back to this figure. Well, we said that collecting data and store it and then presenting it is a general thing in monitoring. But is that what we want to know? I guess not. I mean, monitoring is not about drawing graphs. Well, there must be some purpose for monitoring. We always have some purpose. And for engineers, we need a map for a system. We have to know what's happening in the system. And without monitoring, we will never know what's normal. So we can never find the anomaly. And getting data in advance makes our failure handling speed up and can be able to focus on important works. So there must be some concrete purpose for the monitoring. And the next question will be, what information should we collect? And before going to that question, we have to talk about, we have to think that there are two types of monitoring. One proactive and the other reactive monitoring. A proactive monitoring means we can find problems beforehand by looking at this kind of a big graph or any kind of those things, and find out signals of unusual things. And on the other hand, reactive monitoring is to be called by a phone or poked by Slack or something, and check what's happening afterwards something happens. So these are quite different type of monitoring. For each types, we need specific information. Like, if you're looking at proactive information, we don't want to see the CPU or just the memory of each servers or each switches, each ports of networks. That's too precise to look every day. So we want to see statistic metrics that briefly shows what the system is like right now. Like, how much access do we have right now per minute? Or what is the CPU average for the servers? That's a cattle and pets thing. And on the other hand, in reactive monitoring, we need any information, any precise information. Because after something happens, we have to drill down what's happening or what kind of error has happened. And, oops, sorry, okay. So Datadog says about this, collecting data is cheap, but not having it when you need it can be expensive. So you should instrument everything and collect all the useful data you reasonably can. Collect everything. That's what Datadog says. And that's what I talked about, the reactive investigating part. And we haven't talked about alerting part of reactive monitoring. So let's go to alerting. And too many alerts makes us really confused. And we can't find which one is right. And we never want to receive phone calls in the night, in Sundays. So there must be some better way or some guides to this. And in Prometheus, there's alerting philosophy. There are many things great in this philosophy, but one thing that I want to show you is this policy. Only throw human actable alerts, which means if any alerts come, then a human must move and do something. In other words, if you shouldn't throw any alerts that human cannot work with, you should stop them because they are not required. You should change it to something like notifying or sending emails or just log it. It's not something that you should make a phone calls or pagers. So, and well, alerting is like that, but how should we select what alert to be sent? Is to create the better alerts, we need DevOps. It's not so to say it's original DevOps. We have ops, the operators can create alerts, but they don't know what alert should be meaningful for the actual developers. And so only developers knows what alerts should be sent. And maybe this developers is the server users. So this is quite different. And well, most time developers do not know that much about general alerts. So operators should be gentle about that. And cooperating between developers and operators is the only way to have better alerts. So this is the last slide for today. The best current practices in monitoring and alerting is to prepare to spend time on monitoring. We first need to know this. And then alerts throwing is always have to be the user point of view, because other things won't be something that we can do. And share responsibility about monitoring between dev and ops. Make run scripts, that is a manual when alert happens. And collect as many metrics as you can. That's what I said by using the Datadog words. And alert as less as possible. So monitoring is always about defining requirements. And so never forget that. And the main part for this talk is done. So thank you.